Guys, so today we are going to see how to do principal component analysis using Star software. So Star software is also developed by IRI, which is available free of cost. We can download it from their official website without any cost. So it is an open source software like PB Tools. So PB Tools is also developed by IRI, which we have discussed in our previous videos. So let's see how to do this PC analysis. So let us just start with the data file format in Excel. So this is how you want to type in the data, the genotype column and your trait columns. So this is a simple unreplicated data for principal component analysis. We only need the mean data or your unreplicated data. So just click on this file and go to save as option. Just click on that and just select your file destination. So just give your file name and under save as type you have to select this CSV comma delimiter. So I have already selected this and saved this file, so I'm just not going to save it again. So you have to just click this save option and just close this file. So now coming to the Star software, so just open the Star software now. So the working platform of the Star is very much similar to that of the PB tools. So the same option, there is a tab called project. Just click on that and now select new project. Just give your project a name like a PCA demo. It will be automatically saved in your workspace which you have assigned when you first install this Star. It will ask where you want to save all the analyzed data or your files, your graphs and all. So it will just automatically create a folder called PCA demo. Just click OK. Now you can see there is a subfolder called data. Just right click on that and click on import data. So I have saved it on the D drive under inside the folder Star space. So this is that PCA file. So just I am selecting that and click open. So you can see a arrow pops out. So just click on that. You can see the data file. So just click on that pca.psv. Just click OK. So you can see that the data has been successfully loaded onto the working platform. So with this file we need to now do the PC analysis. So you can see under the tab analyze, just click on that analyze tab, and at the last you can see an option called multivariate analysis. So under that you can go for principal component analysis. Just click on that, a dialog box will open up. So here you have to give your variables, your traits. You have to add all your variables or your traits or your characters to this selected variables box. So these are your numerical variables, germination percentage. Just click on that and click on this add button, or just you can simply double click on this variables and it will just get added to this selected variables box. And another one more box is your id variable. So this will include your genotype. So genotype is your id variable. Just you have to select this and click add. In this case the genotype column has come directly into the factor. If it is not available in the factor, it may be available in the numerical variable box itself. Just you have to select the genotype which is available in the numerical variable box and just click on this set to numeric. So here in my case the genotype was automatically assigned to the factors box. So just I am selecting that and just click this add option. So it will get added. Now before clicking on this OK, just go to this options tab. Just click on this options tab. So you can see there are two options. You can analyze using a correlation matrix of the data, or you can go for variance or covariance metrics. So we usually go for correlation metrics. if our data samples is having traits of different scales, like I have this germination percentage, which is of a percentage, which is calculated in percentage, and I have this shoot length which is calculated in centimeters, and I have this fresh weight which is calculated in grams. So we have different scales here. So if we have different scales in the traits, then you can go for correlation metrics. If every trait is of similar scale, then you can go for this variance or covariance metrics. So usually for the searchers will be needing only this correlation metrics, so select that. Now if you want descriptive statistics of this data, you can select that box also. So number of PC axis is in 3, that is the default, so let it be in 3 itself. So under graph, the scree plot is selected and PCA plot is selected, but we more importantly we need this bite plot. So make sure that you click that, and here you can change the color for each individuals if you want, but automatically the color will be given or assigned. So just make sure everything is right and just click OK. So your operation has been in progress and successfully completed. Now under this output, you can see a new folder has opened called PCA or Principal Component Analysis. So this is the summary statics or your PCA output.txt. Here you can see in the result, the output folder itself, you can see this PCA output.txt. So this is what it has been opened now. So you can see this is the descriptive statistics for each traits, like what is the minimum mean value, maximum mean value, and the average mean, and also the standard deviation has been given. A correlation matrix is also given, a covariance matrix is also has been given here. And as we come down, we can see the ANOVA for the PC analysis. This is the ANOVA for PC analysis. Here you can see statistical data like standard deviation, proportion of variation, and cumulative proportion, how much percentage a principal component is contributing to the overall study. Here PC1 is contributing up to 0.54, that is 54% of the variation is now explained by the PC1. And here, so we can see a whole lot of statistical data here. Here is the aging vectors now. So these are the aging vectors. You can see what are the principal component score or the PC scores for each variables. And when you come just below that PC output.txt, you can see PC scores.csv. So just when we select that, you can see various PC scores for all the genotypes here. So you can make use of what are the interactions. So these PC scores are utilized, or these aging vector values are utilized in plotting these biplots. Biplot 1, 2, these biplots are all plotted using these data only. So whatever you need from these boxes, you can take it for your table creation, for your article purpose or anything. So every data is available here. So now coming to the biplot. So you can see the biplot has been created for PC1 in x-axis and PC2 in y-axis. So as in our PC output, PC1 and 2 just explains majority of the variation. So this biplot will be enough for us. So we can also get a biplot for PC1 and PC3, and also PC2 and PC3 biplots. So whatever biplot is needed for your interpretation, you can get one. And also you can see the PCA plot of the genotypes of this genotypic interaction only without the traits. So we can see that for PCA1 and PC2. Similarly for PC1, 3 and 2 and 3 for the genotypes. So again, also you can have this scatter plot matrix. You will get a scatter plot matrix also and a scree plot. So there is a scree plot also. So that's all about it's very simple doing this PC analysis using star software. So you can make use of this very easily. So that's all for today. Maybe in next video we can see how to do principal component analysis using R Studio. So in that we can see how more detailed a PC analysis can be. We can get lot more information while using R Studio than this start. But this is a simple method. So that's all for today. So hope to see you in next video. Thank you.